Hello again, Worthington Juniors. This MCA review is all about volume. So, let's find the volume. Volume of a prism. Volume of a prism is defined as the area of the base times the height. If you remember from our surface area video, area of the base is capital B. Capital B is not just one number you can pull out of a picture. It is the area of the base. So capital B is actually the whole area. We're going to need to calculate the area. Whether it's a triangle, rectangle, square, we find the area of the base and multiply by the height. And if you know how to find the area of a rectangle, which is length times width, when you plug that in for area of the base, volume of a rectangular prism happens to be length times width times height. Or for a square, all three of those numbers are the same, so you can simplify the formula into s squared. So, when we find the volume of a prism, we're going to take the area of the base times the height. Here we go, let's try a couple. First one, we have a rectangular prism. So if we need to take area of the base times the height, that's our formula, we need to look. What is the area of the base going to be? Well, the area of the base is a rectangle because the base is a rectangle. So to find its area, we're going to take length times width. So we're going to take 10 times 12, and then we're going to multiply by the height, which is 8. So notice, area of the base is actually 10 times 12. Height is 8. We do that multiplying, and we simply get 960 centimeters squared. Centimeters cubed. Volume is in cubic units. We're multiplying three numbers, we get cubic units. So the volume of that rectangular prism is 960 centimeters cubed. Let's try the triangular prism. Notice the triangle here and here, those are your two bases. So when we find area of the base, we're going to have to find the area of this rectangle. Well, how do we find the area of a rectangle? That's 1/2 base of the triangle times base. Let me back up. I was saying how do we find the area of a rectangle? I meant how do we find the area of a triangle? Area of a triangle is 1/2 base of the triangle times height of the triangle. So if we look at this triangle, base of this triangle is 9, height of this triangle is 15. So capital B is going to be 1/2 times 9 times 15. And then we're going to multiply by the height. 12 is the height. It's the number, the length that's connecting the two bases. So again, base, area of the base is going to be 1/2 base of the triangle, height of the triangle, times the height of the prism. So 1/2 times 9 times 15 times 12, we do our simplifying, and we end up with 810 yards cubed as our volume for that triangular prism. Alright, that was prisms. Let's try cylinders now. The volume of a cylinder is the same idea. Same thing. Area of the base times the height. The only difference with the cylinder compared to a prism is that a cylinder always has a circle for a base, and a circle, to find the area of a circle, is pi r squared. So we're always going to have pi r squared times h. But still, the same idea with area of the base times the height. Notice area of a circle is pi r squared, so we need radius. 3 meters is the radius, so we are ready to go with that. We have the distance from the center to the side, that's the radius. So, volume is going to be pi r squared, because that's the area of a circle, times the height, the number connecting to the two bases, which would be 5. So we're going to have volume equals pi times 3 squared, that's the area of the circle, times 5. And if we do just the numbers, notice 3 squared is 9. 9 times 5 gives us 45 pi. I haven't multiplied by pi yet. So what I have done is created an exact volume here. The exact volume of the cylinder is 45 pi meters squared, or excuse me, meters cubed. Now, if we take our calculators and take 45 times pi, we get an approximate volume, which happens to be 141.37 centimeters cubed. So it's possible to leave an exact volume, and that's when you leave it in terms of pi, or an approximate volume, which is when we multiply in pi and get that decimal answer. All right, that was prisms and cylinders. Now it's time for pyramids and cones. So the volume of a pyramid and the volume of a cone is related to the volume of a prism and the volume of a cylinder. The only difference is it takes up a third of the volume because it comes to a point. So all we're going to do is if we have a shape that comes to a point, we're talking a pyramid or a cone, we're going to take 1/3 the area of the base times the height. So again, we're still taking area of the base times the height, it's just this time we're multiplying on by 1/3. So if we look at this pyramid, it happens to be a square pyramid because the base is a square. We always start with volume equals 1/3 area of the base times the height. 1/3 is a constant, capital B, area of the base. How do we find the area of a square? Side length squared. So we're going to have 4 times 4, which is 4 squared, times the height. What's the height? The height is what connects the base to the point. And in this case, it makes that right angle always. It's going to be 6. So this volume is simply going to be 1/3 times 4 squared times 6, which simplifies to 32 inches cubed exactly. So the volume of this pyramid is 32 inches cubed. All right, last shape is a cone. Volume of a cone, again, is going to be 1/3 area of the base times the height. The nice thing about cones is they have a constant shape for their base, and that shape is a circle. And the area of a circle is always found by taking pi r squared. So area of the base is replaced here with pi r squared, and that's what we're going to use. So let's look at our picture. Let's look at our example. We again are given the length from the center to the side, which is the radius. We don't want diameter, we want radius. So the radius here is 7, and the height, what connects the center to the point, using that right angle, that's the height, is 25. So we're simply going to plug this stuff in. We're going to take 1/3 times pi r squared, pi times 7 squared, times the height, which is 25. So we have 1/3 pi times 7 squared times 25. Do a little simplifying with those numbers, and we get exactly 1225 pi over 3 feet cubed. That's the exact. Or we get approximately 1282.82 feet cubed as a volume. That's an approximate volume. All right, that's actually it on volume. That's all there is to it. If you have prisms or cylinders, you're going to take the formula volume equals area of the base times the height. That's it. If the shape comes to a point, meaning I'm talking about a pyramid or a cone, you're going to have volume equals 1/3 area of the base times the height. That's the only difference. Prisms and cylinders, pyramids and cones. Good luck with your volumes.